So, hello everyone. Today I'm going to present my internship work that was done over the summer this year as a part of my master program of biomedical and health informatics. I did the internship training at Renaissance Computing Institute, RENCI. I was affiliated with the translational science team under supervision of Dr. Kimberly Robaski. 3 tasks were done during this internship: data cleaning, precision dosing platform usability, and literature review of generative adversarial networks application in biomedicine. So starting with generative adversarial network, GANs, I get to know a little about GANs, concept and application. This black box, as it's called, that's able to generate realistic, high-quality data, but at the same time, it's unable to explain its performance. This Venn diagram shows the location or the belonging of GANs within the hierarchy of artificial intelligence and machine learning. So GANs belong to the deep learning family of representation learning that's part of machine learning and artificial intelligence. And here you can see the difference through this flowchart between representation learning and classic machine learning. So while in classic machine learning, machines is able to map the output from the input using hand-designed features, in representation learning, machines is able to acquire its own knowledge by mapping features from raw data. This gives the chance for more complex and more identification and selection of the features that suit the outcome. Deep learning take this representation learning ability a step further by allowing representation of complex concepts. This happens through nested hierarchy of concepts. Like in deep learning, they represent, for example, this image features into multiple layers. As you see here, each layer is connected to the following one, and the more complex and more abstract features in this layer is identified through less abstract and more simple concept in this layer, and so on, in order to identify the object identity by the end. GAN is a deep neural network that's architecturally comprised of 2 networks, the generator and the discriminator, that's pitting against each other in a minimax game so the generator transforms the random noise in the data into samples that looks like the real sample and try to do it best so as to fool the discriminator. On the other hand, the discriminator to try to differentiate the input coming to it, is it a real sample or a simulated generated sample? Then the discriminator would, the probability discrimination by the discriminator would go in a backpropagation style back to the generator in order to adjust its parameter and enhance its ability to generate more realistic sample. This process of concomitant and simultaneous training of the generator and discriminator continue until convergence happen, and the generated sample here by the generator is indistinguishable from the real samples. So our approach during the literature review, we used the Google Scholar search engine, and given that GAN was invented by Goodfellow at 2014, we retrieved the articles between 2015 and 18. We specified our search keyword to generative adversarial network and the discriminator to avoid results related to adversarial training, a term that was used before Ian Goodfellow. Also, we excluded publication related to GAN variant, either artificial variant or loss of function variant, and to focus on publication related to GAN application. And here is some example for the search term we used to retrieve all application of GAN. And then in molecular biology, of course, we use GAN and discriminator and DNA, RNA, and protein. Medical imaging, drug development, and other medical application. This graph summarizes the results of our review. As you see here, the number of publications and the years published. By the end of 2018, the number of GAN applications exceeded 4,000, and medical imaging and drug development were among the most common fields of GAN application in biomedicine. While as you see here, regarding molecular biology, it started later than other fields to apply GAN, but at the same time, if you see that all of the fields are growing exponentially at a similar pace. And I'll go through some examples of GAN application. In medical imaging, GAN has been used to generate new images to translate between image modality. For example, this is a magnetic resonance imaging scan, MRI, that has been translated into a CT scan, computed tomography scan. Of course, translation between images, this is a generated new image, would save extra acquisition time, effort, and money. But at the same time, a researcher would question use of this new image in decision-making regarding diagnosis, because although it's a high-quality, realistic image, but the mechanism by which GAN produce it is not fully understandable and interpretable. That's why this is the current research ongoing to try to understand the mechanism through which GAN produce these high-quality images. Another example from medical imaging is to enhance the resolution and to denoise MRI images. One study mentioned that GAN has been used to restore MRI images that have been defaulted by motion artifact. Like in the setting of pediatric, motion during this long study time, the MRI, lead to some artifact that decrease the quality and resolution of the image and of course affect the diagnosis. So instead of repeating the examination, repeating the MRI for the child, you would use GAN to restore and enhance the resolution of the image and of course save a lot of suffering for the child and his family. Still in the medical imaging, in the field of microscopic imaging, GAN has been used to denoise, enhance resolution, and even classify skin lesion in the field of digital pathology between normal and abnormal. In de novo drug synthesis, GAN has been used to create and generate a large set of novel molecules with similar physiochemical property to the training sample. Some studies also mentioned that through transfer learning, this small sample of the training molecules may not be needed because the knowledge GAN acquired through some of the training can be transferred into a new drug development process. In the field of electronic health record, with the barriers to getting access to large amount of data in the electronic health record, either due to health information exchange problem or due to privacy issues, GAN can generate realistic synthetic patient record that can be used secondarily in research and clinical staff training. Another uses of GAN in clinical decision support system, like clinical prediction of opioid use disorder. GAN has been used actually a couple of studies, one in 2016 and it was followed by another one in 2019, to extract the knowledge present in the Unified Medical Language System that's related to the ICD-10 code and medication and the lab. This information was transferred to in adversarial learning to the GANs in order to clinically predict that the current patient who is already on opioid would develop opioid addiction. So through GAN, automatic risk stratification and updating for the model through this data-driven recommendation would adjust the dose in order to prevent such a problem to happen for the patient, especially for the patient who are on chronic opioid treatment. In molecular biology, with the large data explosion coming out from single-cell omic analysis, transcriptomic analysis, although this availability of large amount of data, integrated analysis of these data have been challenged by many biological and technological barriers. So in this field, GAN can uncover a known gene regulatory relationship, and at the same time, it can design novel DNA sequences with specific properties that can be used in treatment, for example. Outside biomedicine, GAN has been used extensively in the field of computer vision. So to test the vision system of autonomous vehicle, to enhance the resolution of the videos, and to identify and classify objects, astronomical objects in the space. GAN has been used a lot, and a lot of application out there in the field of computer vision. Regarding time series data, GAN has been successfully able to generate these kind of time series data and to show better performance than already available model in order to predict future values for weather forecasting and stock market forecasting as well. In conclusion to this literature review, we found that GAN offer great promise in their ability to generate realistic, high-quality data. However, it needs large data sets and special technique to overcome overfitting problem and allow generalization of GAN ability and success. The second thing is the problem of interpretability. GAN is unable to show how it arrived or how it achieved this realistic, high-quality data. So interpretability and validation are active area of research, and they are needed in order to translate GAN into decision-making and in clinical practice. We were able to submit this literature review as a student paper to EMEA 2020, and we are waiting for the response next month. The second project I worked on was a precision dosing platform, which is an ongoing project at RENCI aimed to develop a model in order to accurately predict the drug dosage. My role there was that I provided some clinical insight during the development process, and I conducted usability tests with the team of the developer. And it was an amazing experience, actually. The third task was a data cleaning task. It was on day one, actually, a single task. And I get to know that bioinformaticians spend more than 90% of their time pre-processing the data for analysis. And this was, interesting information to know. I learned a lot through this internship. First, it's giving my background. I know that there is a lot of gaps in clinical practice and research. So getting to know about machine learning potential to fill in this gap and to bridge the gaps between clinical research and practice was great through the literature review I conducted, and also through attendance to a machine learning class that's held at RENCI on bi-weekly basis, through which they discuss the basic concept of machine learning and its application in various research domains. I worked with a talented team of back-end and front-end developer at the precision dosing platform, and it was very interesting to know and to see how much the clinical, during the usability testing, I was giving my insight and feedback from a clinical user perspective. It was amazing how this information affects the work of the back-end and front-end developer to tweak the parameters in order to meet the needs of different users. One of them is the clinical one, the clinical user. I enhanced the professional writing skills during writing the paper, and under supervision of Dr. Kimberly, I was able to build a simple GAN using the Minnesota data library. These are some of the references I used, and I'm really grateful for my supervisor, Dr. Fien, Dr. Kimberly, Dr. Javid, SHIP staff members, and the translational science team member, and all members of RENCI. It has been a great and interesting experience for me. My first experience to work in US, and my first experience actually to work outside the clinical practice, away from the bedside of the patient. I gain a lot of knowledge, and I hope to apply it in my future career. Thank you.
You mentioned that you might speak more about your second project.
The precision dosing platform. Mm-hmm. Yeah, it was, I did that in the skills learning. It's it's very interesting to see that how like a slight feedback from the user, like the clinician or the researcher, can has this large impact on the developing program, for example, for those developer working at the front end, the user interface usability, and at the back end who are developing the model to accurately predict the dose. So seeing the whole project process. Also, I dealt with some of the project managers there. So it was interesting experience for me to interact with various people working at different roles during the project. Yeah, that's it.
I think Eman's role more like contribute her perspective and the evaluation to the platform. That's the way I understand. I think maybe some of the information related to this specific PDP project platform may be sensitive, that if not, she cannot share too much.
And it's still an ongoing project as well. Yeah, so it's still an ongoing project. Yeah.
I think you did a lot. I mean, for your internship. I have a question for your first project.
Yeah, the GAN?
Yeah, the literature review, because I'm a librarian, so I'm always interested in the, how you process the literature.
Yeah.
I think you should keep sharing.
Yeah, I'm keeping sharing. I stopped it?
Use that.
Oh,
Yeah.
So the literature.
So I wonder how many you listed some terms you included in literature search. And I wonder how many, what is the number of literatures you retrieved from Google Scholar?
Yeah, it was about 80 references.
Oh,
yeah, 80 articles. And we had to filter them in order to reduce, by the end, to reduce the number of references in the
So
paper.
you mean that you enter the terms you identified into the Google Scholar search box and you only get 80?
Oh, no, the number of the whole publication, I mentioned in the slide, they were like
I saw
more than 4,000.
4,000.
Yeah.
And so you manually screened all of them and identified 80 of the most relevant ones?
No,
I wonder what's the methodology?
Yeah, so the number of the 4,000 is the number of the whole application, of the whole publication we retrieved, but we scanned only 80 of them. Most of them was related to the biomedicine field.
You only analyze and screened the publications which are related to biomedical and health science.
Yeah, and not all of those related to biomedicine, because there are thousands.
Yeah.
We just selected, we picked from them, the most common, among the most common fields, the medical imaging development was the most commonly, reviewed and mentioned. And molecular biology is the field in which, RENCI has the main concern. So that's why we were other fields also, like in cancer classification, in oncology treatments, it was screened. But of course, because of the small period of time, 3 months, actually I worked on this review, I think, for 2 months, total.
I just wonder, when you first started this project, did you propose to use Google Scholar, or your on-site supervisor or other managers, they think you should start with Google Scholar?
Dr. Kimberly advised me to use Google.
Yeah. So this is Kimberly. So I would first point out that in this figure, you probably noticed that to the left, the y-axis is actually log scale. And that red line, as Eman has already said, is the area of interest for us. So we were looking at biomolecular applications of GANs. And so I did steer Eman with regards to the important papers in the biomolecular side of things. And just, as a point of how the project progressed, the first thing I want to point out is that, if I may offer a little bit of feedback, I think this presentation is marvelous, and Eman did a wonderful job in in her internship, she did a really nice job of fitting in with the team and really providing value at every level. So I really appreciate that. With regards to the presentation, certain attention to precision in language is important, and I wish that there were a few places where I wish that the language had been a little bit more precise. I did not write them down as they went by, so I can't be too precise myself in telling you which specific areas, but specific things. But one of them, for example, is that this was actually not a full review article; it was a mini review. The distinction being made that the entire literature base was not assayed, but thinking to understand the actual thought process. Once Eman had shown such an interest in pursuing and understanding sort of the depth and breadth of how GANs are applied in biomedicine, it became clear that, hey, maybe we should do a broader survey, and that was the consequence, was to create this figure here, which I think really emphasizes how this technology that was invented in 2015 has really taken off, not only in all domains, but also in these other areas, showing that that there's an equal interest across the board. And just going full circle back around to what Eman said, the publications that you pay particular attention to in the mini review is around 80. And you'll see that red line there is, about 100 citations by 2018. And again, she was guided to the more important papers by myself, having worked both in GANs and biomolecular, having bioinformatics training. I hope that answers your question.
Yeah,
And,
very helpful, because when I look at this slide, I look at this, I feel like this is not a mini review scale, this is a lot of paper. And,
yeah.
More than 1,000 at the top, and also each of the line actually is above 100. So I wonder if she really screened all of the publications, or just focusing on a core set that you help her selected. But anyway, I feel like this is an excellent approach for Eman. Especially she was not familiar with this machine learning, and again, all of this in this domain. So I think this is very good to get her familiar with the research landscape, and through doing a publication survey and identifying the key areas, and then pave the way for her to learn more about Python and create again, later. So I'm very glad that you guide her this way, because not every outside supervisor, they will ask a student to do a broader survey, know more about the specifics in the domain, at first.
Yeah, she's Eman, very curious, really fantastic. I've really enjoyed working with you, Eman. And if I can offer one more small sort of nit of a piece of feedback, if you're giving a presentation and it's not for any kind of commercial benefit, I don't know what the licensing rules are for using figures. This figure that we're looking at here, Eman generated, so this is a unique, but I think there were some other figures that I would have liked to have seen the reference to, even if it's just, the author and the year and the journal that it was published in. And I think that might have helped a little bit also. And having said that, oh my gosh, Eman, you learned so much and you did so much, and I'm so proud of you.
Thank you.
I think Eman put all the references in the last slide. I wonder if you look at the last slide, she put all the, I totally agree with you. I think she should put some in-text, citation.
Every time you go to the end of the PowerPoint, it closes you out.
No, it's okay. Actually, in the slide of the references, there are a lot. So I selected some of them and the list are there in the transcript of the report for my internship. So all of the...
But still, I think Dr. Kimberly, she suggested you to put the in-text, in slides.
Oh, in slides.
In the slides,
Okay.
if you use other people's, images,
Yeah.
you should acknowledge that by insert a citation underneath.
Okay,
Underneath the pictures,
Yeah.
underneath the.
And it can be very simple. It can just be, like I said, the author, the year, and the journal, or it could be the URL, or it could be even a shortened link where you borrowed the image from.
Yeah, I will do it.
And beyond that, in terms of licensing, for using other people's images, I cannot talk to that. I don't know. I don't really know the IP law for that in that regard. I think it's okay to use it if you're not using, if you're not receiving funds for giving your talk. But be careful about that if you are presenting in a, at a conference at AMI or something like that.
Yeah, is Google images should be referenced, like those retrieved from Google?
If you retrieve from Google, usually we put the URL, the link, the website link there. If you cannot find the author name, who owns the images.
Yeah. Okay.
That's right. I agree with that. Yep.
Okay. Thank you.
Can I ask a question? In such a fast-moving field with that logarithmic scale, it's not just doubling every year; it's 10xing every year. Are there strategies in place for you to maintain relevance? If you're using a model that's 6 months old, it's extremely out of date. And so you're coming not from a place of knowing about deep learning and GANs. How do you know whether what you're reading is relevant? How do you maintain at the forward cusp of the research?
Yeah, actually, most of the GAN application were in fields, if you go back to the graph, in fields like molecular biology, most of the application started in 2016.
Right.
So I was mainly depending on the keywords, like I'm looking in application for example, medical imaging. So in medical imaging, we started since 2015. I'm trying to pick some application in 2015, 16, 17, and 18, and select from them because of this large number of application. GAN is, as you said, every few days or maybe every day, Dr. Campbell, correct me, they would update the model with either new architecture. There are two main variants for GAN. Variant depending on the architecture of GAN, and another variant depending on the loss of function that GAN used in order to map the output from the input. So every now and then there are new architecture and there are new experimented loss of function. Some of the old, or what's called vanilla GAN, invented by Goodfellow, still used, but some addition to it are there. So I was mainly focused on the application and the year, not on the GAN architecture or GAN variants. Yeah, go ahead.
Yeah, and I was just going to jump in because I think the question was sort of more of a broad strategic in nature, which I wanted to protect you a little bit, Eman, because it's a little bit unfair in your 3-month internship to kind of understand where is the field as a whole going. And but what I could kind of offer is, and Eman, probably you saw the same thing in your mini review, is that a lot of these papers are, as you said, about application. It's really not around the basic research on the computational development of these ideas about generative and adversarial networks, but rather about the application of this particular idea that came to fruition in 2015 by Goodfellow et al. And so what we're seeing is an explosion of interest in actually applying Goodfellow's ideas in the biomedical sciences and in other sciences. And so there are for sure There's research being done on, as Eman said, on the architecture. There's also a very active area of research is on interpretability. So now you have this thing that can generate realistic data. Can it tell us how it's so good at doing that? That would be incredibly useful. And so that's an active area of research. Keeping up on that probably is a lot less strenuous than keeping up on what models are out there that have already been trained to solve the kinds of problems that you want to solve. And so, having said that, I don't know that you need to keep up on that so much, because maybe the right approach is, if you have a problem that you need to solve, take one of the vanilla GAN architectures off the shelf and train yourself a new model. I mean, it's almost easier to do that than to keep up with it. But really this figure is showing the excitement around this technology and more about the applications of this technology than it is, I think, showing the moving of that technology. Would you agree with that, Eman?
Yeah, of course. It's the problem that many researchers in either medical imaging to diagnose a patient or in drug development to approve this drug, they mentioned the two problems of GAN. It's needs interpretability. We need to understand how GAN achieve such high quality realistic images or data. And at the same time, we need to validate, we need to test what's going in modeling in the wet lab in order to make sure that these can be transferred to the decision maker in the clinical or in clinical field practice or research. So interpretability and validation are active areas of research that are very needed in order to translate GAN into practice. Yeah, thank you, Dr. Kimberly.
Thank you.
Any other questions?
What's your next step?
Yeah, this is a hard question. Actually, I plan to graduate next semester, May 2020. At least I'm interested now to, I was like navigating through all of what I learned through this master program. I'm still having this passion to work in the field of computational precision medicine. Because it linked me with what I did before. I'm still navigating how to do that, but at least now I arrived into what I wanted to do.
Yeah.
How to do it is still under investigations.
I believe
Or
if
search.
you find a position and get that position, you will have on-site mentors and managers who can help you grow.
Absolutely. Thank you so much for your advice since day one when I came here.
Oh,
And
you're welcome.
and your mentorship. You and Dr. Kimberly also did a great job. Through, as you say, it was like a short period, and I learned a lot from Dr. Kimberly and from the people there at Trinity. The working environment there is very, charming and respectable.
Very glad to hear you had a successful internship.
Yeah.
Are you still doing work with Dr. Kimberly?
Actually, this can be offline. Yeah. we finished an ongoing project. We are still discussing if we should do another project or not. Still, we didn't finalize the decision. But yeah, it was an interesting experience. Either I continue with them or not. Yeah, it was interesting. Yeah. And so thank you so much for your attendance, and I really appreciate your help, Lindsay, to arrange for this thing. And
Congratulations.
yeah, thank you. Thank you.
Thank you, Dr.
Well done, Eman.
Thank you.
Thank you for letting me.
Oh, thank you.
This is fascinating. Thank you so much.